welcome to this Partners in Research live event. We're brought to you obviously by Partners in Research and also the University of Calgary. My name is Stacey Joyce. I'm the VROC Program Manager at Partners in Research and your host for today. It is my great pleasure to introduce our esteemed guest, Dr. Robert Thirsk, retired CSA astronaut and Chancellor here at the University of Calgary. Thank you so much for joining us today.
My pleasure, Stacey.
So we also have 4 groups of summer campers joining us today. Please give us a wave and say hello when I introduce you. So first we have Partners in Research STEM camps in Ancaster. Ancaster, can you give us a wave? Okay. And we have Partners in Research STEM campers in London. Can you give us a wave and a hello? That was quite the hello, London. Woodstock is unable to join us in the video conference, but they will be tweeting their questions, and I'll be asking those for you, Woodstock. Feel free to let me know the name of who's asking the questions so that I can let Dr. Thirsk know that as well. And here in person at the University of Calgary, we have the Minds in Motion Senior Technology Summer Campers. Can you guys give a wave and a hello? All right. We've got a lively bunch today, I think.
Absolutely.
So a couple housekeeping items just before we begin. I will interject periodically to invite each camp location to ask Dr. Thirsk a question, making sure kind of everybody gets a chance. And if you're watching the live stream and you have a question, make sure that you tweet it and use the hashtag AskPIR. So that's Ask Partners in Research. We are monitoring Twitter throughout the event, so make sure that you post questions there if you're not in the video conference or here in person, and we will make sure to ask them. So to kick things off today, that's enough bookkeeping. Dr. Thirsk, maybe you can let us know how you found your way to the Canadian Space Agency.
Sure. Well, first of all, thank you to Partners in Research and Minds in Motion for inviting me to be with you today. I understand that this is the last week that you'll have your camps, and I'm delighted to be part of your summer. I'm excited about the new school year, and I'm sure you are as well. Let me start off by telling a story. The story takes place in a very small town in Canada many years ago. And on this particular day, a grade 3 boy went into a classroom with his other classmates, and the teacher announced that a little bit later in the morning, a special event was going to take place, and the class would listen in on the classroom radio. So at the appropriate time, the teacher turned on the classroom radio, and that grade 3 boy and everyone else in the classroom heard the voice of a man who was speaking over a background of static to what seemed like another group of people somewhere else. And the man was using all this verbiage, this lingo that no one in the classroom understood. So the teacher explained that this man was actually an astronaut, and he was actually in space at that moment. He had just launched 2 hours before, and he was inside a tiny spaceship that wasn't much bigger than that of a telephone booth, going around and around the Earth. And when it came time for that astronaut to drink or to eat, the teacher said that the man had to take his drinks out of a plastic bag with a straw. He had to be very careful that after he took his drink that he closed that straw again so that the water couldn't get out because it would float everywhere. And when he had to take time to eat, he didn't eat with a knife and a fork and a spoon. Instead, he had to squeeze the food out of something that looked like a toothpaste package so it didn't float away and got directly into his mouth. The teacher also explained that on the spaceship there was a window, not a big window, about this big, and when the astronaut looked down at the Earth, he would see not cars, not people, not buses, not trees, but he would see entire seas and entire continents with one view. And the teacher explained that a little bit later in the morning, when it came time for the astronaut to return back home to Earth, that he would turn his space vehicle around backwards and fire his rocket engine, which would allow the spaceship to come back down into the Earth's atmosphere, and then a big parachute would come out and lower the capsule back down into the water, where he would be rescued by search and rescue teams there that were waiting for him. So, as you've probably all guessed by now, that grade 3 boy was me. And that was the first time in my life that I ever heard the word astronaut. It was the first time in my life I ever heard the word space. And that was an important moment for me, because I decided at that moment that if I ever had the chance, that I'd sure like to become an astronaut and work in space. It seemed so challenging. It seemed so different. It seemed like a lot of fun. My teacher explained that a lot of education was required, so I went on to the University of Calgary, where I got an engineering degree several years later. And I went on to a couple other universities where I broadened my education. And then finally, Canada was ready to have its own astronaut program. I applied, and I was very, 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 very fortunate to be selected as one of the first Canadian astronauts. And I've had a couple of opportunities to fly in space, once on the space shuttle, and then once aboard the International Space Station. So that's how it started for me, how I joined the Canadian Space Agency. It started in a grade 3 classroom with a dream.
It always seems to start with a dream, doesn't it? So let's start taking questions, because I bet all of you have many questions. I have one first to kick us off from Woodstock, and they want to know, what training does it take to go into space?
To become an astronaut takes many years of training. In order to qualify to be an astronaut, it's required that everyone have at least one university degree. And we're looking for a university degree in science, or in engineering, or in medicine, or in health, or in aviation or piloting. So those are the backgrounds that we're looking for. But the other thing, too, is that you can't have just head knowledge. You have to have physical strength as well. Living in space is hard on the human body. Muscles get weak. The heart gets weak. Bones demineralize unless you do something about it. And what we need to do is, before flight, we need to condition our bodies so that our bodies are robust and continue to exercise on orbit. So health and physical fitness is also a requirement to prepare for space flight. And then I guess the last thing for the Woodstock questioner is that we're also looking for people that have a certain personality as well. And in Ancaster, London, Woodstock, and Calgary, you've been working this week in teams, doing a lot of hands-on exercises. That's the kind of skills that we're looking for in astronauts. If you're the kind of person that would rather work on a project by yourself and not listen to the advice of other people, you unfortunately don't have what it takes to be an astronaut. Everything that we do is done in the setting of teamwork. So we're looking for people who have a broad scientific or engineering or medical or aviation background, good health and fitness, and people who like working on teams.
All right. Let's go to Ancaster for our next question. Does someone in Ancaster have a question? And perhaps you can introduce yourself with your name first before you ask your question. I think we've got a frozen video for Ancaster. Do we have Ancaster audio?
Yes. Say your name. My name is Veronica, and the question is, what kind of missions have you taken as an astronaut?
Thanks for your question, Veronica. I've been on 2 space missions. The first space mission was aboard the Space Shuttle Columbia. In the large cargo bay of the Columbia shuttle, we had a laboratory. So we spent 17 days in space doing research. Research in either medical science or research in something that we call materials science. Now, let me take a minute to tell you about the unique laboratory that space can offer us. In space, we have the effect as though there was no gravity. So things float. If I let go of my glasses, they would float away. If I poured myself a glass of orange juice, the liquid would come up out of the glass, form a large ball, and float away. And that's a nuisance for living in space. Imagine trying to go to the bathroom like that in that kind of an environment. But for scientific research, there's no density differences, there's no convection, there's no buoyancy, there's no sedimentation, and we can do some really interesting research that is just not possible on Earth. So, Veronica, that's the kind of research we did on my first flight. On my second flight, it was a long duration flight, 6 months aboard the International Space Station. So we did the kind of science that I just mentioned to you before. We also did animal biology, plant biology. We did a lot of medical experiments looking at how astronauts' bodies decondition in space and what we can put in place to help future astronauts be able to endure even longer duration space flights. I also, because I'm Canadian, had the opportunity to operate the Canadarm2, which is the large robotic arm that Canada contributed to the International Space Station program.
Very nice. What was that like?
You know, I've always worried about making a mess in space or damaging equipment. But we spend years working with simulators on the ground before flight in order to get trained. And the simulators and the quality of the training is so good before flight that I had confidence when I arrived on orbit. And when I operated the actual Canadarm2, it behaved exactly like the simulators on the ground. So that was very heartwarming for me.
Excellent. So let's go to London for a question now. Does someone in London have a question?
Hi. My name is Morgan. And I want to know how much air is in an air tank.
Hi, Morgan. You're absolutely right. In space, we need to bring along a lot of our own what we call consumables with us. So when I use the word consumables, I'm talking about nitrogen, I'm talking about oxygen, I'm talking about water, I'm talking about propellants. And we do bring along air as well. But you know, we can't bring along an unlimited supply of air. We can't bring along a lot of unlimited supply of water. So we have to recycle everything. So the air that I breathe out is picked up by the life support system inside the spaceship and then recycled back in to produce more oxygen and more nitrogen. Same thing with the water. When I sweat, when we wash ourselves and create wastewater, even when we urinate in the toilet, that water is recycled to make drinking water for us the next day. So the joke that I tell my crewmates is that the coffee that I'm drinking today, you're going to drink tomorrow. That's a big joke amongst the astronaut crew. All of the air tanks that we have aboard the space station, the space shuttle, vary in size. Probably the air tanks that you're most interested in are the air tanks that we have in our backpacks when we go outside of the spaceship to do an EVA or a spacewalk. And there's enough air in there for us to do usually a 6-hour spacewalk, but if we have an emergency situation or have a lot of work to do, we could breathe on the air in the air tanks for 8 hours.
Wow. Okay, well, we have a fantastic audience here live because they've been so attentive and so quiet, but I see some hands up and I think it's time to have a question or two from Calgary. So I'll let the counselors go ahead. Maybe you saw who had a hand up first. All right, so if you can come right up here, I'll pass you the microphone. Can you tell us your name first?
My name's Beata, and I was wondering, how long have you been an astronaut for?
Good question, Beata. I've been an astronaut since the very first recruitment of Canadian astronauts, which took place in 1984. So I retired 2 years ago as an astronaut, so I was an astronaut for 28 years. That included 2 space flights, a lot of simulations on the ground, undersea simulations, and other simulations where we were in what we call hyperbaric situations as well. A great job. I worked with great people, and it's just been the perfect career for me. Fun every day.
Good. Let's take one more question from Calgary before we go somewhere else.
I'm Darren, and my question is, what was the main, the biggest reason that fueled you to become an astronaut?
Good question, Darren. What was the biggest reason that fueled me to want to become an astronaut? I think it's, I'll actually give you two reasons, Darren. One is the sense of discovery. I, like you and like your friends in Ancaster in London, have a desire, a curiosity to learn how the human body works, how the world works. So I wanted to go to another laboratory, that of space, and find out how space science works. I always want to discover, I want to learn new things and bring that knowledge back home to Earth to improve manufacturing process, improve health treatments for people on Earth, and just to push the frontiers and go further and further into difficult environments, space, explore another planet. And I guess the second reason why that motivated me to become an astronaut is I want to do something different. I think that I am most productive, that what I do is most meaningful when I'm, what I say, outside of my comfort zone, which means that I'm doing things that I'm not fully qualified to do, but I can always learn something that can then help me accomplish that task. I'm sure you've had those kinds of situations as well. And when you accomplish a difficult task, you get this wonderful feeling of gratification that, yes, I have that ability to be able to do that, and I can always push myself in order to be a little bit better. So I think that was the other motivation.
Great question, Darren. So I have a question now from Twitter. Mm-hmm. So Julia attended camp in Ontario earlier this summer and tuned in today to ask, do you ever have nightmares about things going wrong from your time in space?
Ooh, Julia, great question. First of all, let me talk about dreaming. I found that when I was in space that I often dreamed about being back home on Earth. And now that I'm back on Earth, I often dream about being in space. And for the most part, the dreams that I have on Earth about space are about wonderful things that have happened to me in space or could potentially happen to a future astronaut in space, kind of an adventure. Once in a while, there are dreams, nightmares that feature things that go wrong in space. One thing we don't want to have happen in space is a crash between two space vehicles. As when I launched on my second flight, we came up in a Soyuz Russian vehicle. It's again about the size of a telephone booth, and it has to dock with the International Space Station. It has to come in very accurately, very precisely, and very slowly when it docks to the docking port. And we do a lot of training on that to make sure that doesn't go wrong. And so I've had nightmares about that docking not going right.
All right. Good question. I hadn't thought of that one. So we're going to go back to our Ontario camps for a couple questions, and then we'll come back here to Calgary. So Keelan in Woodstock wants to know, did you do any experiments with zero gravity? So Woodstock is not in the actual video conference, but they tweeted this question from Keelan.
Keelan? So Keelan asked, did I do any experiments that involved zero gravity? Yes, the majority of the experiments that I did on both of my space missions were done with the parameter that we're investigating of weightlessness. A few involved radiation, which is another characteristic of the spaceflight environment, but the most involved weightlessness. Now, let me talk about one, a Canadian experiment from New Brunswick. If you've ever gone to the lumber store with one of your parents to buy some 2x4s or some lumber for a home project, what your parent and you want to do is to look at the lumber that's uniformly white, because that's the strongest plank or the strongest 2x4 you can buy. But sometimes there's some wood that's got this patches of brown in it, and you don't want that wood because it's not as strong. Well, a scientist, Dr. Rod Savage from the University of New Brunswick, thinks that the reason why those brown, poor parts of wood form is because of gravity. So he asked me to do an experiment in space. We flew a bunch of willow trees from New Brunswick on the space station. First time that trees had flown in space. And he asked me to do something unusual. To take the seedlings and to put a 360-degree circle into the seedling. Because if we do that on Earth, bad wood, we call it reaction wood, will form at the top and at the bottom of the loop that someone would put into the seedling. So he asked me to do that in weightlessness and to see whether or not gravity played a role in the formation of poor wood. Obviously, the reason he wants to do the experiment is to see if he can find a way of improving the quality of lumber that New Brunswick Industries produce. But that's just one example of many of the kind of weightlessness research that we do in space.
Excellent. How about Ancaster again? Can we have a question from Ancaster?
My name's Aurora, and how are rocket ships made?
Hi, Aurora. Rocket ships are made in a variety of fashions, but the basic one looks like a long tube. And most of the weight of that rocket ship is actually fuel. If you want to bring something up into space, like a satellite, or experiments, or astronauts, or food, you need a massive amount of propellant in order to get that rocket off the ground and up. Typically what happens is the rockets are made in more than one stage. So when the rocket leaves the Earth, the bottom stage is firing its engine, and soon all that fuel is gone. So that rocket stage falls off. It might parachute back down to the Earth. Then the second rocket will ignite, and that next stage will take the payload or the astronaut up the rest of the way into space. So that's your typical rocket. And that's what you see on TV, that's what you read about in books. But it's very, very expensive way of getting people and hardware into space. And I'm hoping that some of the people listening to the Partners in Research and Minds in Motion videocast today will think of a better way for us to get people in space and hardware into space. Right now, maybe tens of people per year fly in space. When you're my age, I'm hoping there'll be tens of thousands of people in space. But we have to find a better rocket or a better way to get people in space. It's way too expensive right now.
All right. Let's go to London. London, do you have a question for us?
Hi, my name is Sammy, and I was wondering if what would happen if you lost connection coming to land back on Earth from space?
Would you repeat your question one more time? I only got half of it.
What would happen if when you're coming down in space, you lost connection when you were trying to land with NASA?
I still didn't understand all the question, but I think you're asking if what would happen if the spaceship had a difficulty when it returned from space back to Earth?
Yes.
Okay. And specifically if we lost communication. I think everything would be okay. When we get ready to come back home in our spaceship, we absolutely need to have communication between the ground and the spacecraft, because the ground sends up commands to our onboard computer that tells the rocket engine when to fire and when to parachute to come out. And as long as we get those commands up from the ground to the computer, from that point on, for the next 50 minutes or so, we would be okay. We'd be able to execute the return on our own. The difficulty might be for the search and rescue team on the ground. They wouldn't be able to know precisely where the capsule and the astronauts landed, so they might have to hunt around a little bit for us. Inside our capsule, we have some survival gear. We also have some water and food rations as well. So if it takes 1 or 2 days for the search and rescue team to find us, the onboard astronauts will be fine.
Okay. Good question. Let's go in-house to our campers here in Calgary this time for a question. Come on up.
Now, if you don't mind, I have 2 questions. The first one is, when you were riding on a spaceship, what was your part? Like, were you the pilot? Were you someone who made the food? What
Okay.
were you?
And what's your other question?
And my other question is, how fuel efficient is a rocket ship?
Good question. The first question is, what was my role on the spaceship that took us from the launch pad up to space? So in astronaut lingo, my job was called Flight Engineer 2, which means that I sat on the right side of the spaceship. The commander sat right in the middle, and then my other colleague, my other friend, was Flight Engineer 1. So the commander, our friend from Russia, Roman Romanenko, had control over most of the land, over the launch, and also he sent most of the commands to the onboard computer. Frank and I sent other commands. We monitored the systems, so if there was a problem with the oxygen level, or if the engine didn't fire as long as it should have, or if we needed to do a particular maneuver, we'd grab the books and give them to Roman. That was our duties as flight engineers. I'm sorry, I forgot your second question.
It was how fuel efficient is a rocket ship?
Oh, yeah. Well, that's the problem that I talked about a minute ago. Rockets are not very fuel efficient. They burn liquid oxygen and liquid hydrogen, for example, and that combustion goes very well. But it's just, the problem is you have to take up so much propellant into space to get a small amount of payload or human beings into space. That's the part that's not very efficient. So the space shuttle weighs only 100 tons, but we probably need about 5,000 tons of fuel to get it up there. That's not very efficient. We've got to find a better way of doing that.
Thank you for your question. Let's do another question in Calgary before we take off to Ontario again.
Okay. Hi, my name is Raina, and I was just wondering, how do you exercise in space?
Hi, Rita. You're absolutely right. I mentioned to you before that the human body deconditions in space. So probably every single organ system in your body is somehow affected by spaceflight, but primarily the muscles, the bones, and the heart. So we spend 2 hours every day exercising. Half of the time we do what we call aerobic exercise, which is good for the heart and the lungs. We have 2 machines aboard the space station for that. One is a treadmill. But we need to have straps around our shoulders and around our waist to hold us down to the treadmill. Otherwise, our feet wouldn't stay on the tread. The other exercise machine that we have for aerobic exercise is a stationary bike. And that's a lot of fun, too. But in weightlessness, you actually don't need to have a seat on your bike. You just stand up there and pedal away, and it works perfectly fine. For the muscles and the bones, we have a muscle resistance exercise that in astronaut lingo, we call it ARED. It stands for Advanced Resistive Exercise Device. And Raina, would barbells work in space? No, they don't, because if you lift up a barbell on Earth, it takes a lot of effort to get it up. But in space, a barbell weighs nothing, and you can move it around with your finger like that. Just there's no resistance there. So we don't use barbells in space. Instead, we have another machine that gives us an exercise workout like a barbell and a dumbbell workout. So we can exercise our chest, we can exercise our legs, and again, we spend about an hour or so doing that type of exercise every day. So we're quite diligent about exercising in space. It prepares us for any emergency situations that could occur on orbit, and it also prepares us for the return back to Earth's gravity.
Thank you. Good question. So Jenny in Woodstock would like to know, is it hard to walk in space?
Interesting question, Jenny. When I answered Raina's question about exercising, I mentioned we do have a treadmill in space. Of course, on the treadmill, we spend most of our time running on it, but there are also modes of operation for the treadmill that we can walk. Again, we need a harness around our shoulders and our waist to hold us down onto the tread, but walking is totally fine in space. The difficulty is when we come back home. because I was very dizzy and lightheaded when I got home. And I needed someone to hold me by the arm to stabilize me for the first 12 hours after I got home, because I tended to fall over. And when I turned corners, I tended to my shoulder would hit the corner of the corridor. So I had to be careful about that. In space, except for the treadmill, we really don't walk. We fly around like Spider-Man or like Superman. That's the best way to get around.
So what about when you are outside of the space station or your spaceship?
Same thing. When we're outside the spaceship, we fly around like Superman. We never use our legs, except for stabilization. Our legs sort of float in the breeze behind us, and we use our arms and handrails on the outside of the space station to pull us around.
Okay, that must be so difficult to get used to.
It's a surreal world. It's a completely different world than what we're used to here, and you have to do a mind flip in order to adapt to spaceflight. It took me maybe a good week or so to adapt to this new environment and learn how to move around efficiently so that I didn't hurt equipment and I didn't hurt my crewmates. Excellent.
Well, let's go back to Ancaster for another question. I think they just joined us again. We lost them for a sec, but Ancaster, does someone have a question there for Dr. Thirsk?
Hi, my name is Braden. How does a rocket ship work?
Hi, Braden. Rocket ships today, we call them chemical rockets because they burn propellants. And when I use the word propellant, I'm talking about fuel, and I'm talking about oxidizer. So fuel, for example, when your parents fill up your car with gas, gasoline is the fuel. And in the engine, that fuel is combined with oxygen from the air for combustion inside the engine, and that helps you to go. We do the same thing for rockets. We bring a fuel, which might be liquid hydrogen, and combine it with an oxidizer that might be oxygen, and that creates combustion and energy and propulsion. Other propellants might be powdered aluminum. I don't know if you have a chemistry set at home. If you've ever tried to burn those aluminum strips, they burn very well. And we combine that as a fuel with another oxidizer. That's ammonium perchlorate. That's what the two solid rocket boosters on either side of the space shuttle uses to get up into space. Extremely powerful propellants. So today we use chemical rockets.
Excellent. So I think we have time for at least one question from each location. Let's go to London next for a question. Does someone in London have a question?
Hi, my name is Sarah, and I was wondering, how long and where did you study?
Hi, Sarah. Good question, because you're absolutely right. There's a lot of studying that's required to be an astronaut. First of all, I went to university for 4 years, actually here at the University of Calgary, where I am right now, and studied mechanical engineering. I then went and studied another 2 years of mechanical engineering in Boston at MIT. Then I did another 4 years of university at McGill University in Montreal to study medicine. And then I became an astronaut. And astronaut training is continual learning all the time. So 28 years that I was an astronaut, I spent 28 years training as well, in classroom settings like what you're in today, but also in simulators and at home reading manuals and books.
Lots and lots of studying to be an astronaut. I somehow don't find that surprising, though.
I think any fulfilling profession in life, being an astronaut or a school teacher or a scientist or an engineer or a medical doctor, you really have to understand that learning is lifelong. Things change all the time. What I learned as an engineering student here at the University of Calgary has completely changed, and I would be a bad engineer today if I relied only on what I learned a long time ago. And therefore, I need to keep learning to keep current and using cutting-edge tools.
Great. So, when you were in space, Cameron in Woodstock would like to know, how did you use those tools for sleeping?
Cameron, there's 2 ways to sleep in space. So I'll tell you the proper way, and then I'll tell you another way. So everything, as I mentioned to you before, floats in space. So glasses float, pens float, papers float, books float, and human bodies float as well. And that's because in a weightless environment, there's no gravity that pulls you down to the ground or into a chair. So in order not to float around during the night, we sleep in sleeping bags. Now remember that the space station has its own life support system. And therefore, there's continual pumps and motors and compressors and fans that are operating all the time so that we can stay alive. And that creates quite a racket. So when I go to bed at night, I put earplugs in to diminish the noise. The other thing, remember, is that when we orbit around the Earth, we orbit once every 90 minutes. So 45 minutes of sunlight, 45 minutes of darkness. 45 minutes of sunlight, 45 minutes of darkness. So what I do when I go to bed is I put an eye shade on, similar to the eye shades that you might have worn on an airplane before, and that's so that I can see darkness as I sleep. And I always worried before my first flight whether or not I would sleep well in space, and the answer is yes, I did. It's the most comfortable bed, weightless, and there's just no mattress pressure on your bed, on your back, on your front, and you just sort of float like a drown-proofing position. If you're a swimmer, you know what drown-proofing is like. Very, very comfortable. So that's the proper way to sleep in space. The other way is, if you wish, you can simply just put in the earplugs, put on the eye shade, and then just float throughout the night. And the air currents inside the space station will blow you around very gently, and you might come up and you might hit one of your crewmates, but it'll be very gentle, and you just bounce off and you go back in some other direction. And it was always interesting to wake up the next morning and try to figure out where you were, because you might end up upside down and in another module, and that was a lot of fun too.
So if you really needed a good night's sleep, you could use the sleeping bag, and if you felt like you wanted a sleepy adventure, you could just see where you ended up in the morning.
That's exactly right.
All right. Well, last time we asked for a question in Calgary, we had quite a few hands, so let's come back to Calgary for a question. What do we get? Okay.
I'm Cole. I'm just wondering, what kind of training do you do before you leave and go into space?
So Cole asks, what kind of training do we have before we go into space? I guess the first kind of training is that we have what we call systems training, which means that we need to understand how our spaceship works. Because if we're out of communication with the ground, as one of your colleagues asked earlier today, we're responsible for the spaceship. The Russian Soyuz vehicle is a very complicated spaceship to operate. The American Space Shuttle is a very complicated vehicle to operate. And the International Space Station is extremely complex to operate. So when I talk about systems, I'm talking about life support. I'm talking about electrical power. I'm talking about thermal control, about the computer systems, about the guidance and the navigation. And all of these systems, I need to learn how to operate. And that takes years of learning in order to learn that. We do that in a classroom setting, but we also do that in simulators as well, where our instructors put us into awkward situations where we're having a real bad day on orbit, and they ask us to fix the problem. The other part of the training is learning how to operate the experiments. When I flew in space, we had over 100 experiments from around the world that needed to be operated. It's professors and graduate students who ask us to operate their experiments for them, and I want to do it correctly because they spent many years of their career and their education trying to prepare these experiments for flight. So I spend many months, maybe a few years, learning how to operate that. And then the last aspect of training is emergency procedures training. Flying in space is dangerous. I've lost some friends during space flights, and so we have to be able to know how to deal with a fire in space, how to deal with a depressurization of our spaceship, and also how to deal with medical emergencies and toxic atmospheres as well. So the third part of our training is learning how to deal with emergency situations in space.
Good question, Cole. So now we're actually going to go to Ancaster for a question. Ancaster.
We actually don't have any more questions, sorry.
Oh, that's all right. I bet there might just be another question here in Calgary. Last question. Okay.
I've got two. Have you ever seen Gravity, and what happens if the second rockets don't turn on?
I did see the movie Gravity. In fact, I saw it on the first day that it came out, and I loved it. The movie scenarios were an astronaut's worst, not nightmare, but nightmares. Everything that could go wrong did go wrong in the plot of that movie there. So that was a really exciting, dramatic movie that I enjoyed. Of course, there were some technical inaccuracies. There's some things that I saw portrayed in the movie that were unrealistic. But I can put that aside and just enjoy the movie for the excitement. The things that they got right were the interiors of the spaceships, the shuttle, the Soyuz vehicle, the Chinese vehicle, and the International Space Station. They portrayed a flame in space, I thought, very well. And then also the view of Earth from space. They did quite well on that. And I'm sorry, I forgot your second question.
So I believe it was what happens if the second rockets don't work, right?
So as I mentioned before, living and working in space has dangers associated with it. And so we always have backup systems. So our motto in the space program is fail operational. Now that's astronaut lingo, but what it means is that if something fails, like a rocket engine fails, we have a backup that will perhaps be another rocket engine that will allow us to be completely operational, completely functional, able to meet the mission objectives. And then we'll also have a third backup, or a second backup as well, which might will work, but it may not allow us to complete the mission, but at least it'll get us home safely. So if the main rocket engine fails, we'll make use of something else, perhaps the thrusters on the outside of the space vehicle, fire them for a very long period of time and make sure that we can get home safely. Good questions.
Yeah, good questions from everyone today. Oh, a cheater question.
Then the ground would have to consult with the astronauts, and we would come up with some kind of solution. We'll never always try to put a rescue plan in place.
Good stuff. Well, that's all the time we have for today. I'd like to thank everyone again for joining us, all the different camps who gave us such great questions. And I'd like to invite Shane from Minds in Motion to come up.
We'd like to thank you for coming here, so here's our gift.
Oh, well, thank you very much.
Oh.
Thank you.
All right. Thanks also to the University of Calgary for making it possible for us to connect today. And once again, thank you, Dr. Thirsk, for taking the time today to share your experiences and to tell your stories. They were all very, very interesting. I hope everyone enjoyed it as much as I did. Perhaps if you enjoyed it, you can give us a wave or a clap for Dr. Thirsk today.
Thank you to my friends in Woodstock, London, and Ancaster, and Calgary. They're all great questions. I hope that you will consider a career in math or science or engineering or medicine in your career path. It's very fulfilling. And if my friend Kevin Kugler is listening, a shout out to Kevin.
All right, excellent. Well, have a wonderful day, everyone. Maybe you can all just give us one last wave, and we'll sign off.